Welcome back, everyone. Um, I went to the park today and looked at some of the Ramda documentation for the functions starting with the letter I, and some interesting ones in here. Some of these we've already looked at as well, so we'll go through these much quicker than I thought. Uh, the first one we're going to look at is the identical function. And so this one's really very straightforward. We'll start with the type signature. It takes an A and another A and returns a Boolean, right? Because what we're doing is we're returning true if the arguments are identical and false otherwise. So take two things and then determine if they're identical or not. Values are identical if they reference the same memory, right? So objects would be identical if they um, if by reference instead of by value. So we still don't have the whole thing where it's checking like if this is equal to that. In JavaScript that is false because each object has its own location in memory. But if we did const a equals an object and then const b equals a, then go ahead and just do it. R dot identical A and B, and that should be true. Uh, sorry, control. There we go. Sorry about that. And that is true, right? Identical because they reference the same things. And then, of course, 7 and 7, that's true. But the string 7 is not true, false. Um, so to continue, values are identical if they reference the same memory. Um, and that's strange because I think that's more for objects and arrays because I don't think the strings 7 and 7 occupy the same memory, but they're true. So I think that's just something you're supposed to know. But the thing is, not a number is identical to not a number. So this is a problem in JavaScript is not a number, triple equals not a number is false, right? And just for whatever reason, this is just one of those weird JavaScript things. Like maybe that's the best thing, maybe it's not, but it's probably not what we want to consider. And I mean, in your daily life, you're generally not checking if not a number is equal to not a number. But sometimes weird things come up because don't forget about the clients. The clients make us do weird stuff. They make us go down weird rabbit holes. Um, so that's what it does. 0 and -0 are not identical. Again, like why are you messing with 0 and -0s, right? Like unless you're doing some weird science stuff, and if so, like you're probably using Python or something like that. So 0 and -0 are not identical, but the triple equals um, says that they are. So object dot is, yeah, here we go. Note that this is merely a curried version of ES6's object dot is. So we had, a long time ago, we had the double equals, and that would check if two things were equal after being coerced into the same type. So, if you had 0 and the string of 0, since these aren't the same type, it would change this one to a number, and then we could check. Um, so, that would be true, but Then they introduced the triple equals, which does not do type coercion and checks if the values are true in terms of the value and type. And so that would be false. Um, but then we had that weird thing where 0 and -0 are true, but object. So they created this object.is, which is kind of like a fourth equal sign. Um, so if we did object.is, it's a static method, um, and we checked 0 and -0, that will give us false. And if we checked not a number and not a number, that would give us true. And that's what it's saying. Not a number is identical to not a number. So if you ever have this weird use case, you can use object.is, or you can use r.identical, and that is true. And so it's the exact same thing, but it's curried, right? And then so you could do like a function called const is identical, or is we could say there is there is a function called is not a number, and then there's like a number dot is not a number, and that's confusing. And then there's some other trick where you check if the value is equal or not equal to itself. Um, you can look that up if you're interested. So I'm going to call this my is not a number and do r dot and identical and partially apply with the first value, and then do that, and that gives us true. So really, just this is really the whole definition you need to know. This is merely a curried version of ES6's object.is. So boom. Um, Pretty straightforward. Gotta love this type signature A, B, and Boolean. Like they just kind of phone that one in. Um, so a relational one, and there we go. And this next one is even simpler. And this is like identity. This is like the very first function in functional programming. And there's actually something called SKI combinator calculus. Um, the S stands for the S combinator. Stands for constant, which we've looked at. It's the always function. It's the function that just always returns the same thing. And whether you provide an argument or not. Um, and then the identity function that we're about to look at. And those three functions together create a Turing complete um, programming language. I assume you would also need to use recursion so that you can loop and stuff. But apparently, you can do anything with just these three functions. Um, I dare you, try it. Look it up though. There's some fun information about it. But getting back to identity specifically, it's a function that does nothing but returns the parameter supplied to it. Good as a default or placeholder function. So if were to create our own, it would be identity takes an X and returns an X. Done. No more complicated than that. So we log the identity of 4. We're going to get 4. Bob, we get Bob. I mean, there's really just no more to say about it. Now, the question becomes, when is this useful? And it is. Uh, I've had 3 or 4 moments where I found that the identity function was a good thing to use. And when I did, it was such a good feeling because it made me think like, oh, there is a point to this. People aren't just pretending like it's a necessary function. That said, I can't remember any of those scenarios. Um, when we get to the if else state function, which is next, we can use it in there. Um, yeah, it comes in handy a lot. And here's something you could do is go to the documentation, do a find on page and type in identity, right? And there's like 22 occurrences in here. And I don't want to look at the ones that are kind of complicated. Um, but yeah, here's like an unnest. I think we looked at that when we looked at flatten. Unnest just unflattens um, an array one level deep, right? So, but it's saying it's a shorthand for r dot chain, which we've looked at. That's the flat map, and r dot identity as the callback function to r dot chain. So it basically like just takes the values and returns the values, and then r dot chain flattens it. So there are use cases for it. Um, but I don't know really what else too much to say about that. We'll look for places where we can use it, and we'll use it in the next one. I'm going to go um, straight into if else. I was just pausing for a second to make sure there wasn't anything else to look at. I mean, let's look at how they implemented identity. Uh, it's coming from internal identity. There you go. One line takes an X, returns an X. They just did it using a function statement. So yeah, that's the identity function. And then we'll go into the if else function. Now the if else function, I rate it highly on cool points, um, especially when you're using a pipe. So let's get rid of this and let's dig in. So we know what an if else statement is, right? And we know what a ternary statement is. I feel like I'm insulting your intelligence if you're watching this and I demo what that is. So the if else function is like a ternary in a function, but we can compose functions. So if we're using a pipe or a compose or something or flow, we can use our if statement without, you know, doing some separate block of code. Um, it takes three arguments. All three are functions. So the first function takes anything and returns a Boolean. Because like an if else statement or a ternary expression, the first thing is your expression that returns true or false, decides which branch to go to run, the successful branch or the true branch or the false branch. Um, so then it takes another function, anything to anything, and it can take any amount of arguments. It's a variadic amount of arguments and returns anything. And that's going to be for the true branch. And then it returns another function, same thing, variadic amount of inputs, and returns anything as the output. And then it returns uh, a function that takes anything, any variadic amount of things, and returns anything. Let's expand the parameters and see. So a better way to say that is the first argument is a predicate function. Predicate function takes returns true or false. The second one is the onTrue function, a function to invoke when the condition evaluates to a truthy value. On false, when the condition evaluates to a falsy value. And then it returns a function that will process either on true or on false, depending on the result of the condition. So sounds logical. Um, we'll see an example of how to use it, and it might become a little bit more clear. But so it creates a function that will process on true or on false depending on the result of the condition. Note that if else takes its arity from the longest of the three functions passed to it. So I guess that's a side note. They're all variadic, but if the first one takes one argument and the true branch takes one argument and the false branch takes three arguments, then the arity of this entire function that's returned is going to have it's going to be an arity of three. So that's just something to keep in mind. Uh, Let me just steal this code example. So ink count. So okay, so we get to use that has count. So I guess I'm passing an object, and we're going to see if that object has a count. Oh, you know what? We're using lenses here. Let's make our own function. I don't want to get into how lenses work right now. So let's just go through it. So the first one takes a predicate function. So why don't we do um let's use a random function and say r dot flip r dot greater than and three. All right. So the first thing we'll do is we'll check if the value that we're passing in is greater than three. And then based on that, we'll do a true branch, just trying to think what to do. I mean, we could just do an anonymous function here and say it's big. And then in the false one, we'll just do another one and say it's not so big. So let's see if I got that right. So let's see, clear that. It'd be good if I called the function, right? Let's not call it int count. That's what it was from the example. Call it is big. I don't want to say is big because that makes me want to say true or false. I want to say size message. I don't know. Naming things is hard, especially when you're doing it live and recording yourself. Right? So that should be a function. And we need to pass a number. So we'll say size message 32. And we get it's big. And if we did just two, it's not so big. So I mean, it is an if else function, not an expression, not a ternary expression at least, and not a function statement. Uh, Functions in functional programming do return expressions. They evaluate the expression and return the result. So this technically is an expression, but it's a function. So like I said, we could use this in a pipe. We could say on a pipe, and we can say to do R dot filter, and we could pass it the same is greater than, but we'll do it's greater than six. Come on, prettier. Why are you doing this to me? Yeah, R dot filter. And then we'll do like R dot map. And then I think we'll just double it. We'll do R dot multiply 2. Tell you I'm kind of obsessed with spacing these things out like this. Okay, and then we'll do our R dot if else. And we'll just use our, let's do this. Let's go back here, change this to 3. I mean, for no real reason, but, and then I'm going to use a similar function here. Oh man, that's driving me crazy. On it flip, on it kit 3. So that's our predicate. And then we need our success one, and then we'll use this. And for our false case, we'll use this. Yeah, formatted a little better for me. Let me just make this a little clearer. Yeah. So here's our if else. This is our predicate. This is our, let's see. Here we go. Our predicate, our true, and our false. Um, and then this is not, this is returning something. Let's just do this much. Make sure that works. You know what? I need to pass it a value. I'll just do it right here and say 1, 2, 3, 4, 5, 6. Wait, yeah, that's an array. Yeah, we get it's not so big. So let's not run it in our heads. Let's use this r dot tap thing. We can tap into our pipe and we'll log what we want, and we'll just do each step at a time. So we're passing in the array. There's our array. Um, Ignore the message because it's still going to return that. In fact, we'll just comment it for a second. All right, so there's an array. 2, 3, 4, 5, 6. Where's the 8, 9, 10 coming from? Am I logging something else in this file? 8, 10, 12. Wait a second, what am I doing? Just do that. 8, 10, and 12. What in the world? Oh, well, I guess I'm returning something. Okay, I'm sorry. Maybe it's just getting a little late for me. Okay, forget the 8, 10, 12. There's the 1, 2, 3, 4, 5, 6. That's the thing I'm passing into the pipe. The next thing I'm going to do is I'm going to filter it and to get the values greater than 3. So I should get 4, 5, and 6. I don't think I saved it. There we go. I get 4, 5, 6. Then I'm going to double it. So I'm going to get 8, 10, and 12. And that's what we're seeing output. below. So we're going to pass 8, 10, and 12 into our if-else function. So that doesn't really make sense. It's just checking the first item probably, or it might even be saying is the array bigger, and it's probably giving us like not a number or something. Um, so it'd make more sense to map this. R dot map, and where does it end? It's right here. Maybe that'll work. Yeah, it's big, it's big, it's big. So let's change this to predicate if the number is greater than 10. Yeah, it's not so big, it's not so big, and then it's big because we got 8, 10, and 12. Um, yeah, but the point is it's composable. I mean, we could keep adding to it. Let's see, it ends here. Maybe I should put this on its own line, yeah. And then I could do like r dot join with an emoji of some sort with tacos, right? It's not so big, tacos, not so big, tacos, big, right? So I just find that incredibly useful to be able to use an if else expression inside of a pipe, um, and just keep flowing that data just from the top or bottom, or no pun intended, the r dot flow map function. Um, in fact, it should be so easy to change that. I'm just going to do it. To take that and make it the first argument, and then the other functions are in an array. Save that, and we should get the same thing, but we don't. Oh, I didn't rename the function flow. Right? Like very cool, very handy. Um, so yeah, that's the if else statement. Um, I'm just going to do one more because I'm flowing, and these are so simple. The increment function, it takes a number and increments it. How about that? So again, let's just make our own. I mean, we looked at decrement before, and we've looked at increment. So just real quick, it's inc takes a number and increments it by one. Inc 41, 42. And you could also do it like this: point free r dot add one. And if you want to decrement, you can always add minus one, which is much simpler than doing subtract or flipping subtract and then applying subtract to the number. You got to deal with the which order the numbers are in if with subtraction. But if you're adding minus one, it works as the first or the second argument. So that should give us 40. Um, yeah, I mean that's all there is to ink, and of course we've looked at it. And this is probably a good place to stop this video. Looked at identical, identity, if else, and ink. And we've looked at index of before, and we've just looked at init. So we'll pick back up with includes, and depending how long that is, maybe do another one. Anyway, as always, thank you for spending your time with me. Tell a friend, and I will see you when it's time to talk about includes.